Hi everyone, thanks for checking out this video. So this video is going to be a little bit different than most of my previous videos. So in the past, I've showed you guys how to write computer simulations of stochastic models for example, like stochastic models of gene expression, stochastic models of like population growth and things like that. And I've showed you guys this technique of like writing a computer simulation and trying to analyze the results of it. But there's actually another way to study stochastic models, which is by using analytical, like mathematical methods rather than simulations. And both ways of going about like analyzing a stochastic system have advantages and disadvantages. But I think it's good to know how to do both of them. So in this video, I'm going to be sort of doing a lesson related to stochastic analysis from like a mathematical point of view. And I'm trying to kind of start with the very basics. So this is going to be a video about this concept called an expected value. And if people are interested, I might keep making like more videos on like the mathematics of stochastic systems. But yeah, I thought I'd just make some kind of like basic video about this concept of an expected value. So I'm going to try to explain the definition of it and then give some intuitive examples of like how to understand it. And then I'll show you guys in Python how to do a sanity check by writing a simulation to check our results. So okay, that's a bit of an introduction, but okay, let's get into it. So what is an expected value? So the definition for a discrete random variable is the weighted average of all possible outcomes of the random variable weighted according to their probability. And this is for a discrete random variable. It's a little bit, the way you calculate it for a continuous random variable is it's calculated differently. But for our purposes here, I'm going to be talking about discrete random variables because I'm trying to make this like something easy to understand from first principles. And I think talking about discrete random variables is easier to understand. But yeah, this is kind of like, I kind of paraphrased the definition I found on Wikipedia. So it's basically just a weighted average where you weight all of the outcomes of a random variable according to probability. But what does this actually mean? Like that's kind of the definition, but what does this actually mean and how do we understand it intuitively? That's the question for this video. So let's just forget about like any like math and computer programming and all that stuff for a second. Let's just forget about that for a second. And instead, let's just talk about gambling and try to build up some intuitive sense for how to talk about if a bet is like a good bet or a bad bet. Okay, so let's say we're betting on the outcome of a fair coin flip, meaning 50% chance it'll be heads, 50% chance it'll be tails. No one's cheating or anything, just fair coin. So let's say that in the first scenario, if it turns up heads, you win $5, and if it turns up tails, you lose $5. So before we talk about anything like an expected value or anything, just think to yourself, like, is this a good bet or a bad bet, or is this kind of like a fair bet that's kind of neutral? But okay, let's say a second scenario, if it turns up heads, you win $5, and if it turns up tails, you lose $50. So in this scenario, just think to yourself, is this a good bet or a bad bet? And is this a better or worse bet than scenario 1? And then scenario 3, we'll just say if it turns up heads, you win $50, and if it turns up tails, you lose $5. So again, just kind of ponder on this yourself, like, for these three scenarios, which bet seems like a good bet, which bet seems like a bad bet, and which bet seems like a fair or neutral bet. So if you guys are kind of like using common sense here, you probably notice that scenario three seems like a pretty good bet because it's like 50% chance of winning $50, and there's a 50% chance you might lose, but if you lose, you're only losing $5. So it seems like it's a very favorable bet to you. And in scenario 2, it seems like a bad bet because it's basically the reverse. So the amount that you're losing outweighs the amount you're winning. You know what I mean? Because you're winning and losing half the time each, but your losses are going to be a lot greater than your wins. And then scenario 1 is a fair bet because it's like 50% chance you win, 50% chance you lose. and then the amount you're winning is the same as the amount you're losing. So this is a fair bet. But okay, so that's kind of like the common sense way of thinking about it. But how would we actually describe like the goodness or badness of these bets in mathematical terms? So this is where we can think about expected values and start to sort of gain some intuition for them. So it's like we said with the definition, an expected value is the weighted average of all possible outcomes where they're weighted according to their probability. So for these ones, we said it's a fair coin flip. So the probability of each one is 50% or 0.5 probability. And then we have our payout values, which are the values that we're trying to get an expectation of. And then so to compute the expected value, we just do this calculation where we multiply the possible value, we multiply it by the probability of that value occurring, and then we just sum those up so that we're getting a weighted average of them. So if we do this for like our fair bet example, we can kind of see that it's going to be 0. The expected value of this is going to be 0 because it's a probability 0.5 times the outcome of 5 plus a probability of 0.5 times the outcome of -5. And if we just compute that out, of course, it equals 0. And then we can also do this for scenarios 2 and 3, where we just, again, we just multiply the probability of each outcome by the value of that outcome. So it's for scenario 2, it's 0.5 times 5 plus 0.5 times -50, because if it's tails here, we're losing $50. So we just do the same calculation, but we see here the expected payout in this case is a negative expected payout. That's what we mean when we say something is like a bad bet or an unfavorable bet. It means that it has a negative expected payout. And then for scenario 3, we just do the same thing again. It's just 0.5 times 50, because if it's heads, we win $50, plus 0.5 times -5, because we're losing $5 if it comes up tails. So when we do that calculation, we have an expected payout here that's positive. So that's what we mean when we say something is like a good bet or a favorable bet. It has a positive expected payout. And okay, guys, so this is a quick public service announcement too. So this is also why you should avoid going to casinos, because if you go to casinos, all of the games have at least a slightly negative expected payout for you, because the casino is trying to make money off of you. So all of the odds in all the games in casinos are not fair bets like in scenario 1. They're more like scenario 2 in the sense that they have at least a somewhat negative expected payout for you. So yeah, if you're trying to gamble, don't go to casinos, because yeah, all of them have like an expected negative payout. But yeah, just some notes on notation here. So this is the expected value notation for a random variable x. So you might see it like these with these like angle brackets. That's how I usually write them. Or you might see it like e brackets and then the name of the random variable. These both mean the same thing. They mean the expected value of this random variable x. I usually use this kind of notation. I think it's just simpler and like easier to read. But yeah, you might see these two like e brackets and then your random variable. And so this is like the math formula. Again, I want this to be like as intuitive as possible, so I don't want to give you guys a bunch of like confusing notation. But if you see this formula, this is just kind of writing down like mathematically in like a formal way how to do the computations we just did. So it's basically, if you have some random variable x, it's kind of a convention to talk about the specific values that random variable can take in just like the lowercase letter of the random variable. So talking about like x as our random variable here, we want the expected value, so we put it in these angle brackets. And then we basically want to sum up all of the possible values of our random variable. And then for each value, we want to multiply it by the probability of that value occurring. So I know this might, if you're kind of a beginner with this might seem like some confusing notation, but this is just taking the summation of all these things and basically summing over like iterations of I, and for like every x sub I corresponds to some outcome that we could observe for this random variable. So for every x sub I, that's like either the heads outcome of 5 or the tails outcome of -5. That would be our xi, except it would be like x sub 1, x sub 2, x sub 3, and then just keep going for each of our possible outcomes. And then the p of x sub I is just the probability of observing that outcome. So like, for example, for I equals 1, our x sub 1 would be 5, and then our p of x sub 1 would be 0.5. That's the probability of observing this outcome of 5. And then we just go through and then do it like for our second possible value of I, which is our second possible value of our random variable. That would be -5. So our x sub 2 here would be -5, and then p of x sub 2 would be 0.5. So again, like, I'm sorry if this is kind of a bit of confusing notation, but I just want to include this at least somewhere because it'll be good to at least recognize this notation and hopefully understand what it means and how it's really not so complicated. Basically, it just says we're going through every possible outcome of our random variable and multiplying the value of that outcome by the probability of observing that outcome, and then just summing all of those up. Okay, so that's just a bit on like the official like math formula notation. So what I'm going to show you guys next is how to do a sanity check for the results in Python. So again, this was like a very simple example where we can like for these things here, it's so simple that we can just like kind of trust that it makes sense. Because the calculation was like so simple. But when you get to doing like more advanced stochastic models, these sanity checks become very important because you want to make sure you didn't like screw up your analysis of the system at any point. You know what I mean? You need to like make sure that the simulation you're writing like matches with your analytical results that you did mathematically on paper. Because if it doesn't match, then that means something's wrong. You know what I mean? So this is kind of a simple example, but I'll still show you guys how to do it so that we can like build up these we want to build up this solid foundation that we're going to use for like more complex stochastic systems later on. But yeah, and again, just to remind you of the terminology, this is what's called like a Monte Carlo simulation when you're doing a bunch of like random simulations to try to see what the distribution of outcomes kind of looks like. But okay, so yeah, I'll show you guys in Python how to do this sanity check. So we're just going to import two libraries here. So we're going to import random and then import numpy snp. And even the only reason I'm importing numpy here is just to use the numpy.mean to take the average of something. So I mean, we don't even like really need numpy, but I just like to use it. So first we're going to define an empty list to store all of our payouts. And then we're going to make a for loop to basically run this run simulations of this bet like a bunch of times. So we're going to say for trial in range, and then let's do it like 10,000 times for now. Hopefully that'll be enough. And then okay, so for each of these trials, we're going to just simulate this bet on this coin flip that we're talking about. So we're going to say if random.random is greater than 0.5. If this happens, this is basically just seeing if a randomly chosen decimal between 0 and 1 is above 0.5. So this is what I'm using to simulate the coin flip because this has half of a chance of being true and half of a chance of being false. So we're going to say if this is true, we're just going to say that the coin came up heads. This will be our simulated coin flip. And then, so if this is true, we're going to say payout equals 5. Start with the first scenario, the fair bet. And then we're going to say else. So if this is false, we're going to say payout equals -5, right? And then just going to simulate that coin flip. And then after we simulate the coin flip, we're just going to append this payout to our list of all the payouts that we're keeping track of. Okay, so it's really as simple as this. It's really not anything any more complicated, at least for this simple scenario. But again, we want to like start simple and build up our intuition to use in like more complex cases in the future. But yeah, this is all we need for now, and then we're just gonna print expected payout, and then it's going to be the average of all of these, right? Because basically, like another way of thinking of the expected value is if the scenario happened like a million or a billion or a trillion or an infinite number of times, what would be the average value that you would be observing? You know what I mean? So that's another way of thinking about this. If you want to think of it instead of like doing this calculation, we can think of it as if we just do this bet like a million times, what will be the average payout we'll be receiving, right? So this is kind of the Monte Carlo approach to thinking about this. Is we just simulate the bet like a ton of times and just see what the average outcome of the bet is. Okay, so let's see what it is for this this scenario. So yeah, so in this scenario, it's probably not going to be like exactly half of the time turning up heads and exactly half of the time turning up tails. So I mean, we wouldn't expect it to be like exactly zero, like on the nose, you know what I mean? But if we do it a bunch of times, it's going to be like sometimes a little bit above zero, sometimes a little bit below zero, and you know what I mean? So it's like the true underlying value is still zero, but when we do these like numerical approximations, they're going to be like approximations that aren't going to be like exactly, you know what I mean? But it's still like clusters around zero. And if we were to do this simulation an infinite number of times, then the mean of the payouts would be exactly zero. But we can't obviously do like an infinite number of numerical approximations. So when we do it like this, it's just going to be like sometimes above and sometimes below. But okay, so let's try out one of our like unfair bets. So let's try out the scenario 3 bet where we win $50 if we win, and then we only lose $5 if we lose. Let's see what it is in this case. Right. So it's like in this case the expected payout is like a lot more positive. So it's 22.907. I think that was like pretty close to what we calculated, right? Yeah, so the actual like calculated expected value is 22.5. The numerical approximation is like 22.907. And again, if we do this like a bunch of times, it's going to be like different approximations every time, but it's going to kind of like cluster around the true expected value. And then again, we can also do the same thing for the scenario 2, the unfavorable bet, and we're going to see again just like negative 22 point something, right? So yeah, these are kind of some like simple examples, but this is what you would do also for like a more complex stochastic system if you wanted to like check and make sure your analytical solution to it was correct. You would write a simulation and like make sure the simulation results match with your analytical analysis of the system. You know what I mean? So again, this is just like a very simple video, but I'm trying to like build the foundation here for kind of the analytical tools that we can use for like more complex systems too. Okay, hope this video was helpful to somebody. If you guys are interested in this topic, I can also keep making more of these videos. And I think I probably will try to do this. I think I probably will try to like keep going with these like analytical stochastic models videos if I can, if I have time. But yeah, I might try to make a couple more of them, kind of starting from the beginner level and like building up to like more complex systems. But yeah, if there's anything you guys want to hear about in particular, just let me know in the comments. And any questions, just let me know. I'll try to answer them. And yeah, thanks for watching and see you next time.